If you double the voltage applied to a transistor radio, what happens to the current? So I've drawn a little mini diagram of what a very, very simplified version of a radio would look like. We have some sort of power source, such as a battery, and it has some voltage, V. There is also some resistance that is intrinsic to the radio. We'll just call it R. And then there's some current traveling through the circuit, which has current I. And so let's think about this using Ohm's law. V equals IR. Now let's just solve this for I so that we can think about it from that perspective. So if we double the voltage on the radio, what happens to the current? Okay, well, let's write this out again. We have I equals V, but now we're going to call it 2V, just because we've doubled it. And that's still divided by R. In this case, R, the resistance, doesn't change, because that's just a property of the radio. It's intrinsic to the parts, to the wires, so the resistance isn't going to change, because we're not changing the radio, we're just changing the voltage. And so doubling the voltage here is actually just immediately going to double the voltage, or double the current here. If we put a 2 on this side, whatever the current was before is now going to be twice as big. You can think about it another way. If we go back to this original equation here, the resistance is unchanging, so it's the same number. But if we increase the voltage, if we double it, for the left-hand side of this equation to equal the right-hand side, for it to stay the same, we also have to increase the current. Those are a couple different ways that you can think about this. But at the end of the day, if we double the voltage, we will be doubling the current. So doubling V implies that we are also doubling the current I.